Okay, now let's get started. Can you all hear me clearly?
Yes.
Okay, so in the previous lesson, I have posted videos. So we have talked about the structure isomerism. So it includes three types: chain isomers, position isomers, and functional group isomers. And also we mentioned the first type of stereoisomerism, which is geometrical isomers. So it involves carbon-carbon double bond in it. Okay, and again, if you haven't go through those videos, you can check on Google Classroom. So today we're going to move on to the second type of those stereoisomerism. So this one is called, okay, enantiomers or optical isomers. So before I introduce this type of isomer, you need to understand a very important concept, which is called superimposable. Wait a second. Yeah, superposable. Okay, so what does superposable mean? You can take a look at those photos here. Okay, so if we have something and we can find the mirror image of that stuff, and then let's try to put the mirror image on top of the original one. Okay, for example, you can take your left hand and your right hand. Try to put your right hand on top of your left hand and see whether the position of your 5 fingers can match or not. Okay, so when you put your right hand on top of your left hand, you can see the position of your 5 fingers are different, right? So that means they are sorry. That means they are not superposable. Okay, so the mirror image cannot be put on top of the original one and the positions won't match. Okay, so that's not superposable. Again, we got one more example, the shoes. Okay, if we take the mirror image of the left foot shoe and then it becomes the right foot shoe, right? But now try to put the right foot shoe on top of the left foot one. The position of each detail won't fit, okay? It's not the same as the first one. So we call it not superposable. However, we got two more examples here. For the first one, when you take the mirror image of that object, then you can put this and put it on top of the original one, and you can see all the parts of the mirror image to match the position on the original photos. Okay, so for those kind of object, we say it's superposable. And again, for this character, if you take the mirror image, it would just be the same as the original one. So we are going to have no difficulty putting this one on top of the original character. So we say the original character is superposable to its mirror image. Okay, and let me show you some more examples. And I want you to tell me whether it's superposable or not, okay? Give me a second. Can you see my screen now?
Yes.
Right? Can you see that figure I took a photo with? Okay, so sorry, that's not the original one. Okay, so that's the original figure. Okay, so if I flip it horizontally, then I can get the mirror image. Okay, so I put it here. Sorry. Okay, so now can you tell me whether this figure is superposable or not? Okay, yes, it turns out that the mirror image on the right hand side is not the same as the original one. Okay, so we cannot put the mirror image on top of the first figure, and the position of the eyes, the position of the tongue won't match, so it's not superposable. Okay, and let's try more examples. Okay, so for this one, it's a character, and if I take mirror image of that, okay, so that's a mirror image. Okay, so is this one superposable? Yes.
Yes.
So you can see, ignore the background, but if you just look at the figure itself, okay, when you take the mirror image, it's exactly the same as the previous one, okay? So we can put it on top of the original one. All the position of the details, like the nose, the eyes, the ears, it's gonna match with the previous one. So we say it's superposable. So for those character that is superposable to its mirror image, can you find any special things about the image? Okay, one more example. That's the original one, and that's a mirror image. And again, for this one, it's superposable. So what kind of feature those pictures have to make it superposable? It got tons here. It doesn't have to be a character with eyes and nose. It can be just an object, or later on we're gonna talk about molecules. So for those photos I've shown you, what kind of characteristics they have to make it superposable? Yeah, just flip it. Yeah, after you flip the photo, you can see it's still the original one. So what word we use to describe this property? We call it symmetrical, isn't it? Okay, it's symmetrical, so no matter how you flip it horizontally, you can still get the original one. It's still the same. Yeah. Okay, so let's go back to the notes. Oops. Okay, so after understand that very important concept, we go back to the isomers that we want to learn. So if the object that's superposable to its mirror image, we call it achiral, okay? if, okay, if it's not superposable on its mirror image, then we call it chiral. Okay, so you need to be able to distinguish between chiral molecules and achiral molecules or objects in general. Okay, so those are the objects that we come across in our daily life. How about we apply the same rules onto the molecules? So if we scroll down a little bit, we got the first example, bromochloromethane. Okay, here is a model. Okay, so a lot of the time, if we just draw the structure in a 2D way, draw it flat, we can't see the real structure. But remember the stereoisomerism, we talk about the atoms arranged in different ways or different positions in a 3D way. Okay, so I have made a video that shows you the model of this one, so it would make it easier for you to understand. So let's make use of that videos. Example 1, bromochloromethane. So this is a molecule given, for example 1, I have built a model. Okay, so to distinguish between different atoms, I use white to represent hydrogen, I use blue to represent bromine, the yellow one to represent the chlorine. Okay, so the first step, we need to find out its mirror image. So I have built the mirror image, which is here. Okay, so in order to work out whether it's chiral or achiral, we need to see if we can get the mirror image and put it on top of the original molecule, and all the position of the mirror image atoms must match with its position on the original molecule. Okay, let's try it. So if I take this one and I try to rotate it, okay, then I put it on top of the original molecule. You can see it can actually match all the atoms' position with the original molecule, okay? So hydrogen, carbon, right, and the bromine, and also the chlorine. So we say the mirror image is superposable to the original molecule. Okay, so the original molecule is said to be achiral. Okay, so here's the first example, the model 1 given on page 10 of your notes. So for the first one, because the mirror image can be put on top of the the original one, so we call it superposable, hence it's achiral. Okay, and then take a look on the next page, your page 11. I'm going to show you the models for the next one. Yes, because we're dealing with 3D models in this part, so you can actually rotate the mirror image and try to fit the position of all the atoms. Okay, so if you switch to the next page of your notes, and you can watch these videos. Example 2, bromochlorofluoromethane. So that's a molecule given, for example 2. I have built the model and I use the same color to represent those atoms. But you need to note that the size of the ball doesn't match with the actual size of the atom. So please just use it to mark them as different molecules at different positions. So that's the original molecule. Okay, so in order to work out whether it's chiral or achiral, we need to again find out its mirror image. So I have built the mirror image of this molecule. Okay, and then the next thing we need to consider is whether the mirror image is superposable to the original one. Okay, so let's try. If I rotate this, okay, so I put the rotated mirror image on top of the original molecule. Okay, so here I try to match the position of the bromine. Okay, so red one represents the bromine and yellow one represents the fluorine. Okay, so if I match the position of the bromine atom and the fluorine atom, then you can see that the position of the chlorine atom and the hydrogen atom doesn't match. Okay, so how about we match the position of fluorine and, we match the position of chlorine atom and hydrogen atom. Okay, so I rotate the mirror image of the molecule. Okay, now I got the right position for chlorine atom and hydrogen atom. Let's see what happens to the bromine and fluorine atom. Okay, so again, you can see the bromine atom and fluorine atom are not on the same position. Okay, so no matter how you rotate this mirror image, it cannot be put onto the molecule which all the atoms' position matches with the original one. Okay, so in this case, we say the mirror image is superposable to the original.
Your screen is off. The screen is off.
You mean the video? Check. Oh no. Yes. Wait a second. Okay, so again, you can see the bromine atom and fluorine atom are not on the same position. Okay, so no matter how you rotate this mirror image, it cannot be put onto the molecule which all the atoms' position matches with the original one. Okay, so in this case, we say the mirror image is not superposable to the original molecule. Hence, the original molecule is chiral. Okay, so in this video, you can see I built the two models. So on the left hand side, you got the original one. On the right hand side, that's the mirror image. Okay, so I tried two ways to put the mirror image on top of the original one. That's the first attempt. I tried to match the position of bromine and fluorine. But you can see on the left hand side, the chlorine and hydrogen one doesn't match. You can see? Yes, that's example 2 on page 11. Because I don't know which part you get missed, so I'm using the screen to explain it again. Okay, if we move on to page 11, I use the same color to represent the atoms of those molecules. Okay, so the two models represent the original one and the mirror image. Now it's the first attempt I tried to put the mirror image on top of the original one. And this time I only get the position of bromine and fluorine, the red and yellow ones position match. But the chlorine and hydrogen, green and white ones doesn't match, okay? Then I tried the second method. Okay, so now in this position, or in this method, I try to match the position of the chlorine atoms and hydrogen atoms. Okay, if I match the position of these two types of atoms, you can see the red ones and yellow ones, their position doesn't match. Okay, so no matter how you rotate the mirror image, it won't fit exactly the same as the original one. So for this type of molecule, we set it to be chiral. Okay, so the mirror image is not superposable to the original one. Okay, so any question for this part? If not, I'm going to switch to the notes and talk in detail. Okay, so yes, I will solve your problem when I move to that part. Okay, so I think it's pretty clear with example 1. Okay, I have shown you the model. Okay, it's easy to put the mirror image on top of the original one. Okay, so we set it to be superposable of the original one. Hence, this molecule is an achiral molecule. Okay, so it gets a little bit complicated for example 2 on page 11. So the original one is this molecule, and then I build a mirror image. Okay, when you take the mirror image of the original one, actually you just switch the position of any 2 atoms. Okay, that's why on the mirror image molecule you got fluorine that pointing towards the mirror, okay, and bromine pointing towards the mirror. Okay, so after we got the mirror image, we try to rotate the mirror image, okay, and to fit the position on the original one. But as I have shown you in the video, it's not possible. So it's not superposable to the original one. Hence, for this molecule, we say as chiral. Okay. So if we get chiral molecules, when we have a pair of those chiral molecules, we call it a pair of enantiomers. Or we can also say it's optical isomers. Okay, since they are not superposable mirror image of each other. And usually, if we draw a chiral molecule, we will put a star next to the central carbon, and the central carbon we will call it the chiral center. Okay, you can say chiral carbon or the chiral center. Okay, and now let's take a look what's special, okay, or what makes the molecule a chiral molecule. Okay, so first, let's consider the atoms are joined to the central carbon. For the first model I showed you, it got a chlorine and a bromine, but 2 hydrogen. Okay, so the central carbon bonded with 2 identical atoms, which is hydrogen in this case. So that hydrogen, those 2 hydrogen atoms make it symmetrical. Okay, hence it's superposable to the original molecule, so it make it achiral. But in the second model, since we have the carbon attached to 4 different atoms, okay, so in this case, we could not find any plane of symmetry, okay, so this molecule is said to be chiral. So in order to make a chiral molecule, we must have the carbon bonded to 4 different atoms or group of atoms. Okay, it cannot be the same. If it got 2 identical atoms, then we can find a plane of symmetry. Okay, so that moves us to this next part. If we have found out using those examples, if we can find a plane of symmetry, then the molecule will be achiral. Okay, so here, if we got this molecule, okay, because the central carbon is attached to 2 identical methyl group, hence we can find a plane of symmetry here. Hence, this molecule is said to be achiral because its mirror image is the same as the original one, and we can put the mirror image on top of this original molecule. okay, and all the positions of those atoms will match. So for this one, it's achiral. And then if we take a look at the, okay, the next one on the right hand side, this central carbon is bonded to 4 different groups. It has a methyl group attached to it, a chlorine attached to it, a hydrogen, and an ethyl group. So 4 different groups, okay, so make a plane of symmetry on this molecule. Hence, this molecule is said to be chiral. Okay, so that's how we find find out which one is chiral, which one is achiral. Okay, and now we can move on to the checkpoint questions. You can have a go or we do it together. Okay, so the first part, determine with explanation whether the following objects are chiral or not. Okay, so A, the character A, is it chiral or achiral? And what's the reason for that? Okay, I give you some time to think about it, and also I scroll up a little bit. Yes, okay. So for the first character, character A, that's a chiral character, okay? Because this character is holding different things in its hand, okay? Left hand is a spoon, right hand is a fork, okay? So it's achiral. And what's the reason for that? Sorry, it's chiral. What's the reason for it being a chiral character?
Not symmetrical.
Yeah. But when you answer this type of question, please say it's not superposable. Okay, so I'm looking for the keywords. It's not superposable to its mirror image. Okay, and for the next one, B.
Achiral.
Achiral. Yep. Okay, so for B is achiral, and the answer you need to state is superposable to its mirror image, hence it's achiral. Okay, remember to include the keywords. Okay, for question 2. Okay, remember we often use a star to mark the chiral center or the chiral carbon. And can you find those chiral carbons on those 4 molecules? Okay, so maybe I make it easier for us to communicate. So for this molecule, let's number the carbons from left hand side. So carbon 1, 2, 3, 4, 5, 6. So which carbon is the chiral carbon? Yes. Okay, later on I will post the videos on Google Classroom. Okay, for the first example A, okay, number the carbon from the left hand side, okay, because we want to get the lowest number for bromine's position. So carbon 1, 2, 3, 4, 5, 6. Which carbon is the chiral carbon? Remember, the chiral carbon needs to be bonded to 4 different atoms or group of atoms. Okay, so which carbon have been bonded to 4 different atoms or 4 different groups of atoms?
The third one.
Yeah, the third one. So let's Okay, mark it with a star. How about B? Okay, let's try. It got a carboxylic acid at the end, so we can number it from this side. 1, 2, 3. Which carbon is the chiral carbon? Yeah, the second one. Okay, because it got it's bonded to 4 different atoms or group of atoms. Okay, C. How about C? Okay, so the functional group you can see is the OH group here. So to make it have lowest number, we number them from the right hand side. 1, 2, 3, 4, 5. Okay, so which carbon is the chiral carbon? Two. Yes. Okay. This carbon, it got a methyl group, a hydrogen, OH group, and also a propyl group. Okay, a bit tricky one. D. Which carbon is the chiral carbon? So just a bit easier for us to communicate. So I just randomly number those carbon. 1, 2, 3. So which carbon? For example, D.
The
Okay,
first one?
the first one. Okay, so let's try to add those hydrogen, those hidden hydrogens. Okay, so if I rub off the numbers. Okay, so at this position, it should, because carbon needs to be bonded with 4 atoms or group of atoms. So for this carbon, it needs to be bonded to 2 other hydrogen. And for here, 1, 2, 3, already got 3 bonds, so it should be bonded to another hydrogen. And for this carbon, it bonded to 2 hydrogen, okay, and also 1 OH group, okay. So actually, it got 2 identical atoms. These 2 hydrogen atoms make it identical, make it symmetrical. And at this position, the same, because they have 2 identical hydrogens on it. So you got a plane of symmetry here. Okay, so this carbon is not the chiral carbon, nor this one. Okay, it's a chiral carbon. So the only choice would be this one. Okay, for this one, you can take a look. It bonded to hydrogen, also bonded to this part, a hydrogen with 2, sorry, a carbon with 2 hydrogen, and bonded to an oxygen. Yeah, so 4 different atoms and groups of atoms. So this carbon should be the chiral carbon, this one. Okay, so if the question provide you with the condensed structure formula, then you could fill in those hydrogen to remind yourself, and then it will be easier for you to find out the answer. Okay, so any questions so far? Okay, so the next part, suggest which of the following can exhibit a stereoisomerism. I'm not quite understand your questions. Are you saying Are you saying it got 2 chiral carbons? Okay. The system is reminding me I got less than a minute. Maybe I start a new one and then I can answer your questions. Is that okay? Because I don't want you to be surprised because I'm gonna end our meetings. Okay.